Hello everybody, Anthony Lopez here once again on February 28th of 2017. I'm here to help you once again with mathematics. Today I'd like to cover exploring the x and y intercepts through linear equations. My goals that I want to focus on covering in my podcast include defining what intercepts are, figuring out how to find them graphically, and figuring out how to solve for them algebraically. The way I'm going to approach these lessons include the model by Marzano and Brown called the 10 design questions. Now, although I do not specifically go through each of the 10 questions in this podcast, what I do is I set up the 10 questions to create an outline for how I wanted to do my lesson. So once again, I'm not going to specifically go through the 10 questions, but I use those 10 questions to create this lesson. Now, I'm going to do two separate lessons. One which I'm exploring x and y intercepts graphically, and the second being exploring x and y intercepts algebraically. Each lesson should span over one class period, so that these two lessons should take 2 days altogether. The different learning strategies that I used when going through these two lessons include setting goals, providing feedback, homework and practice, reinforcing effort, and cooperative learning. I will talk later after I finish the two lessons as to how these 5 learning strategies were used. Lesson 1. Exploring the x and y intercepts graphically. The goals for this first lesson is basically to be able to define what the intercepts are graphically, and how to figure out how to find what these intercepts are when all you have is a graph to look at. So let's begin. First, let us define what intercepts are. Intercepts are basically the points at which a line cross an axis. So specifically, the x-intercept is where the line crosses the x-axis, the horizontal axis. The y-intercept is when a line crosses the y-axis, the vertical axis. Now this creates a point. So technically, when you go to answer the question, what is an x-intercept, you'd want to write in a coordinate point of x, 0, because the x represents what we find it to be, and the 0 represents the fact that there is no y, it's at y equals 0. Whereas for the y-intercept, it's the reverse. It's going to be 0, y as the coordinate pair, because there is no x, it's, when it's on the y-axis, x equals 0, and then the y is wherever you found it to cross the intercept. So let's look at an example. Here we see a graph that has a line. The white line crosses both the x and the y axes. So let's try and figure out where it crosses them and what the answer would be for the intercepts. So let's start with the x-axis. Like I said, the x-intercept is whenever the line is the point when the line crosses the x-axis. So if you look carefully, you can see that the white line crosses the x-axis at -1. So -1 would be the x-intercept. If you look for the y-intercept, we once again go to the y-axis, and we look, where does the white line cross the y-axis? Here it's going to be at the point 1. Now, like I said a bit ago, the answer should actually be in an ordered pair. So let's look at what the actual answer would be, rather than just the x-intercept is -1 and the y-intercept is 1. So using the little form that I said earlier, the x-intercept, which has the x being -1, and since there is no y value, it'll be at 0, the point should be -1, 0. Whereas the y-intercept, which has no x, it's on x equals 0, and y equals 1, it should be at the ordered pair 0, 1. How about another example, just to see another view of it. Here, the white line crosses both the x and the y-intercept, but it does it a little differently than the last one. Last one it was more, here it crosses the x and here it crosses the y-axis. Here it seems that they do it at the same point. It crosses the origin. It only crosses once. However, because it crosses once both the x and the y-axis, that means we actually only have one intercept point, and it's for both. Think about it. If it crosses the x-axis at 0, which it does, and the y-axis at 0, which it does, then the point, which in the form should have been for the x-intercept x0, would be 0, 0, and for the y-intercept, which would have been 0y, which it's going to be 0, 0, the two intercept points that we have would be 0, 0, and 0, 0, meaning that we have only one intercept point, 0, 0. Let's look at a few special cases. Here we have a horizontal and a vertical line. If you look, they don't have two intercepts. The horizontal white line only crosses the y-axis, and the vertical red line only crosses the x-axis. These two cases are the only indefinite lines that will have one intercept when we're talking about linear equations. And you'll see later on what they do algebraically. But for now, just remember, if you have graphically a line that it looks like it's parallel to one of the axes, it's only going to have one intercept. An activity to be able to help students become engaged in graphing includes separating the group of students into two subgroups. Group number 1 we can call the graphing group. Group number 2 we can call the identifying group. Things that are necessary for this activity include basically some sort of board, whether it's a whiteboard or chalkboard, and some sort of writing utensil for such. So if it's a whiteboard, you need dry erase markers. If it's a chalkboard, you need chalk. But what you do is you have the first group go up to this board and basically draw a graph. Each student draws a graph. And when the first group is done, the second group goes up and tries to figure out where the intercepts are. They want to identify them, in the coordinate point form. After that's done, you can, if you have enough time, switch the groups and have, the second group become the graphing group and your first group become the identifying group. This is a really good activity because it allows the students to just have some fun. It allows them to, draw the graphs and see what the answers would be, and then figure out what the answers to their friends' graphs would be. Lesson 2. Finding x and y intercepts algebraically. The goal for this lesson is to be able to define and solve for x and y intercepts algebraically. So let's begin. The definition between graphically and algebraically is only slight when it comes to x and y intercepts, but it may help. X-intercepts algebraically are the value of x when y equals 0. Vice versa, the y-intercept is the value of y when x equals 0. Now, the normal form that we normally work with, and most of the time will be easier for us, is when it's in the form y equals mx plus b. This is slope-intercept form. Now, the process for solving these equations starts out with the definition I just said. Algebraically, we solve when we know that the intercepts occur when at one variable the other equals 0. So at x-intercept y equals 0 and y-intercept x equals 0. So all we need to do is plug in 0 for one variable to solve for the other variable's intercept. Let's do an example. If you're given the equation y equals 2x minus 4 and told to find both intercepts, you'd start out, you could start with either x or y, whichever you prefer. I started with x. So to find the x-intercept, I plugged in 0 for y to solve for x. So the equation y equals 2x minus 4 becomes 0 equals 2x minus 4. We solve algebraically by adding 4 to both sides because we want to get the x by itself. So instead of 0 equals 2x minus 4, we get 4 equals 2x. To get x by itself now, we divide by 2. So that 4 equals 2x becomes 2 equals x. Since x equals 2 when y equals 0, we want to once again put it in the form that we did with graphing. We want a coordinate point. So, knowing that x equals 2 when y equals 0, we can just use those numbers. The point is 2, 0. So next we find the y-intercept. We plug in 0 for x and solve for y. So that the equation becomes y equals 2 times 0 minus 4, which 2 times 0 equals 0, so that y equals negative 4. Once again, since we used x equals 0 and y equals negative 4, our ordered pair coordinate point would be the point 0, negative 4. Let's do another example, something that's a little different. What if we were given the equation 3x minus 6y equals 18? This isn't in slope-intercept form. It's not in y equals mx plus b. So what do? There's two ways we could do this. First, we could look at it as if put it in slope-intercept form. If you think that's easier, go ahead and do it. Whatever works better for you, use it. However, since all we're doing is plugging in 0 for one variable to solve for the other, we can keep it in this form. That's what I'm going to do. So once again, I found the x-intercept first. I plug in 0 for y, so that we have the new equation 3x minus 6 times 0 equals 18. Negative 6 times 0 equals 0, so 3x equals 18. And we just need to divide by 3, such that x would equal 6. The ordered pair would then be 6, 0, because x equals 6 when y equals 0. To find the y-intercept, we plug in 0 for x and solve for y. So, it's not going to be as easy as last time, but we plug in 0, so we have 3 times 0 equals 3 times 0 minus 6y, equals 18. 3 times 0 equals 0, so negative 6y equals 18. We divide by negative 6, and we would then get y equals negative 3. This gives off the ordered pair 0, negative 3. Now once again, there are two special cases, as we said before, the horizontal lines and the vertical lines. Now these have equations. The horizontal line is in the form y equals c, where c is any number. It could be y equals 5, y equals 3, and that's just the point where you start drawing the line. What's important about this is that there are no x-intercepts. Remember how when we were looking at the graph, a horizontal line never touched the x-axis. So there's only one intercept point, and that would be at the point 0, c, because y would equal c. There is no x to be able to have a x-intercept. Same thing kind of goes for vertical lines. It's going to be, instead of the form y equals c, it's going to be the form x equals c, where once again c is any number, like 3 or negative 5. Vertical lines have no y-intercept. They run parallel to that y-intercept. They never cross it. So all they have is an x-intercept. The x-intercept just occurs at that point c. So the ordered pair would be c0. As I said in the beginning of this podcast, there was 5 learning strategies that I hope to use: setting goals, homework and practice, cooperative learning, providing feedback, and reinforcing effort. The goal of these learning strategies were more so to be used inside the actual classroom setting. So although I was not able to use all of them in this podcast, through the learning session that I developed, these would be utilized. Setting goals was used in this podcast, and is basically my way of being able to allow the class to focus on some sort of specific goal at the beginning of class. If we tell them what to do in the beginning, they know what to expect, rather than waiting and figuring out, are we done yet? Homework and practice, which is the second learning strategy I wrote down, is utilized mainly through in class. I like doing a lot of worksheets and activities to keep the students, active. I also assign some homework, but I usually give the students some time to work on it so that if they have any questions, they can ask me before they go home. But it allows the students to have a lot of time to work on what they're doing. Math takes time, and you have to be able to understand what you're doing, which sometimes comes through repetition. Cooperative learning is one of my favorite things to use. I like having the students, when they're working on these worksheets and activities, as I previously said, I like them to work together. Students who are at the same level are able to help each other learn. I know everything, or so they say, so that when I say something, they're just like, but why? When the students finally are able to grasp a concept and they're able to share it with another student, that's when real learning is happening. So I like to allow the time for students to work together, to help each other, and really come to these realizations together. The last two, providing feedback and reinforcing effort, those I kind of lump together in the sense of when I use them. So as the students are doing their cooperative learning, they're out in their groups and they're doing homework together, they're doing these worksheets and activities together, I like to walk around the room and basically figure out how they're doing and what they're doing, making sure they're on task. So in one sense, I'm reinforcing effort by saying, make sure you guys are on task, make sure you guys are doing your work. But at the same time, I'm going around and I'm saying, you're smart enough, you can do this. I'm reinforcing them, saying, you're good, you can do this. And I'm also giving feedback, they're asking, is this right? I don't want to always just go outright and say, yep, this is right, yep, that's wrong. But I can tell them, hey, you're using the process right. You may be having a few algebraic mistakes, but hey, you're doing this right. Those are the 5 learning strategies that I do use in the current learning classroom. Thank you everybody for listening to this long podcast. I know it's a little longer than I'm used to, a little more in depth, but I hope you learned from it the 2 different lessons of exploring X and Y intercepts algebraically and graphically. If you have any questions, you know how to email me. Just follow the website, contact me, let me know if you have any questions. Hope to see you guys again.